Here it is. Two poles, 10 meters and 15 meters high, are 25 meters apart on level ground. A guy wire runs from the top of each pole to the foot of the other pole. Find the height above the ground of the point where the guy wires cross. Alright, well man, you can already tell in this diagram we got lots of right triangles to worry about. Now I'm going to put the numbers in and see if we can kind of dissect what's going on here. Got a 10 meter pole, we have a 15 meter pole here, and they're 25 meters apart. Now we have to assume, and it's a good thing, that we have to have these poles in straight, and therefore those are right angles. That gives us our right triangles that help us solve this problem. So here's where the guy wires cross, and we want to know how far off the ground, whoops, can't draw a straight line there, how far off the ground that point is. Alright, we're going to have to find some parts of these missing parts of these triangles, and I'll give you a hint before you should pause this video and see if you can figure it out yourself before I show you. What you're going to use is the functions of sine, cosine, and tangent, one of those. You're also going to use inverse functions to find some missing angles there, and given all that, you're going to use two different pairs of right triangles. Alright, so look at all the diagram, look at all those right triangles in that diagram. See if you can kind of break it apart. You might need to redraw the diagram a few times and figure it out. We're solving for x. Alright, here's the first clue. What we're going to do is separate this diagram out into two different right triangles. And we need to find this angle here, which I'm going to call A. Alright, that's that angle right there. And this angle here I'm going to call B. Alright, and I want you to notice the two overlapping right triangles. Okay, we've got this one. Okay, see that? And that's going to be that one right there. And then of course we have the larger triangle. So I'm going to basically call them the smaller triangle and the larger triangle. Now you notice how they overlap here, and therefore we can diagram, fill in the numbers of our other triangles. Now when I fill in my numbers, you notice how it's not too crazy to figure out angle A and angle B. We have to use the reverse tangent function. Alright, so the measure of angle A is going to be the inverse tangent of, now let's think about tangent for a second. If A is my reference angle, tangent is opposite over adjacent, right? So that's got to be 10 over 25. Now since 10 over 25 is 0.4, I put 0.4 in a calculator and I find the inverse tangent of that. Alright, happens to be about 21.8 degrees. Alright, now we're going to need that information here in our next step, but let's just put that in. 21.8. Now similar here calculation is going to be for the measure of angle B. So the measure of angle B is going to be the inverse tangent of, now remember B is the reference angle, so the opposite over adjacent right there, 15 over 25. Now 15 over 25 is actually 0.6. So what's the inverse tangent of 0.6? On your calculator it should give you 31 degrees. Alright, approximately 31 degrees. So 21.8 and 31. Okay, now we're going to need to know that in our next set of right triangles. So we found those two angles, and now we're going to focus back on where the guy wires cross. Okay, now we know that distance. I'm going to go ahead and call it x again. Okay, and again, if we measure the distance here, it's going to give us a right angle there to the ground. So that's why I have these two triangles labeled as right triangles. So we have a 31 degree angle there and a 21.8 angle degree there. And I notice how I have a distance of 25 between the poles, and I'm going to introduce a couple of other expressions here. In the smaller triangle, I'm going to call this distance y, and this distance must be 25 minus y. Okay, just a little trick here. I'm going to introduce a second variable, excuse me, and it's going to look like this. Alright, now the problem is I have this distance is x. Okay, now I can't use any trig functions here to figure out what x is because we have another variable, y. But here's the key. Okay, a very nice trick you can use in algebra and geometry sometimes. If in a diagram you have an unknown distance that can be expressed with two different expressions, then you can set them equal to each other. Alright, now here's what I mean. The tangent of that 31-degree angle is opposite over adjacent, so x over y. The tangent of this 21.8-degree angle is opposite over adjacent, so it's x over 25 minus y. Now I'm going to multiply, I'm going to get x by itself here, so I'm going to multiply in this equation the tangent 31 times y. Now tangent 31, when you put it in your calculator, is going to be about 0.6. And if I multiply tangent of 21.8 times 25 minus y, that's actually going to be 10 minus 0.4y. Okay, I do the distributive property there. Now I have again x expressed in two different ways, so I can set them equal to each other. In other words, 0.6y, which is what I got from this smaller triangle, is equal to 10 minus 0.4y. So again, I notice that the distance where the guy wires cross, which we call x, is part of this right triangle on the left and a part on the right triangle on the right. We can set them equal to each other with these y expressions. Alright? And that's where I get that equation. So let's go ahead and solve by adding 0.4y to each side. And so y must be 10. Now I just arbitrarily picked this part here as y, so that distance from the short pole into underneath where the guy wires cross is 10. That means it must be 15 on this other side because it's a total of 25 between the two poles. Now we can find x. Alright, back to the diagram. We are looking for x. Okay, now when we draw this distance straight down, that's going to be a right angle right there. And we're going to call that x. Now I just found out that this distance here must be 10. This distance here must be 15 for a total of 25. And I do know this angle as 31. And this angle as 21.8. Alright, believe it or not, that's all I need to know. Alright, let's go ahead and I'm just going to use the left-hand triangle with the 10 on the bottom. We could have used this other one, but I'm going to go ahead and just fill in what we know. We're looking for x, and it's a right triangle. All I need is one side and one angle. Alright, so what trig function are you going to use to solve for x? Well, from that reference angle 31, x is the opposite side, right? So we have opposite over adjacent. Once again, it's the legs of the right triangle, so that's tangent. So tangent of 31 is x over 10. We're going to multiply both sides by 10, and so x is going to be the tangent of 31. So when you put that in your calculator, again, you'll find it's 0.6 times 10. And obviously that's going to be 6 meters. Alright, well again, what we had to do is find these angles first, by looking at the right triangles that are overlapping there, the larger ones. And then we found the distance here where the ground distance was split, so we could find x. So 2 different pairs of right triangles. Wow, challenging problem. And give me some feedback if you like that problem. Write in, give me some more examples. Love to make some more videos. Thanks again for watching.